I want to show you how you can construct present value, future value, and annuity tables in Excel. Now, these types of tables, while they're still in many introductory textbooks, aren't too popular anymore, mostly because most students have a financial calculator or they use the formulas in Excel to solve out the problems. But there's value in learning to do this. Okay, first, it allows you to understand the formula. When you're using your financial calculator, you'll type in present value, number of periods, the interest rate, and then you'll ask it to compute the future value, but it's a black box. You don't actually understand what calculation it's doing. But by constructing a table, you can get an idea of what's being done here. So here, you'll notice that we have the future value equals the present value times 1 plus r to the teeth power. And you'll notice that this factor here is independent of the present value. Oftentimes you'll see in the textbooks, they'll say that this table would be the future value of $1, okay, at an interest rate of R% for T periods. So they assume this is 1. Once you work this out, you just multiply by the present value and you get the future value. So let's see if we can put the formula in here. Okay. Constructing this in Excel is useful because it allows us to understand how formulas go into Excel, how we lock columns, how we lock rows, how we copy formulas. And this is extremely useful, not just in finance, but in many things you'll do. So we start with an equal sign to tell Excel we're using a formula. And we're going to have 1 plus, and the interest rate is in B6, and I'm going to put a dollar sign in front of the 6 because I want to lock the row, because I'm going to copy down this formula and I don't want it to move because the 1% is in B6, it's not in B7, it's not in B8. So I'm going to put a dollar sign there that locks the row. I want to raise it to a power, and this is done by hitting the caret or hat key. It's the upside down V that's Shift 6 on your keyboard. And here I want to lock the column. And here it's in A7, but I want it to stay in A. So I'm going to put $A7. I don't put the dollar sign in front of the 7 because when I copy down, I want it to change to this cell so that it raises it to the second power, third power, fourth power, etc. So I get 1.01, and that looks correct because 1% is 0.01 and 1 plus 0.01 is 1.01. I'm going to change the number of decimal places. Up here, it's quite easy. You can just click and add a couple extra decimal places. I'm going to go 4 places after the decimal. To copy this, I'm going to move my cursor, which looks like a 3-dimensional plus sign, and there's a little box in the corner here, and if you move over it, it becomes a 2-dimensional plus sign. If you hold the left mouse button down, you can drag across, and you can see it copies across, and it looks correct because 10% would be 1.10, 9% would be 1.09, and I can also copy down. Now I've only done this for up to 10% interest rate and 15 periods, but you could do more interest rates, and you don't even have to go in 1% increments. You could go, in 1/4% increments. So you could have 1%, 1.25%, 1.5%, 1 3/4, etc. You don't have to limit yourself to 15 periods. I'm just doing this to illustrate this. So suppose I said you're going to receive $100 today. How much is it going to be worth in 9 years at an interest rate of 7%? So we go down here to 9 periods and we go across to 7%. Okay, so where these two intersect, and we get a factor of 1.8385. So you just multiply 100 times that factor and you get $183.85. So if you put $100 in the bank today for 9 years at a 7% interest rate, you'll have $183.85. Okay, let's do the present value factor. Again, same concept. Sometimes you see present value written as future value over 1 plus r to the teeth power. I've moved the future value out to the side so that you can see that, again, this factor is independent of the future value. And so if we know this factor, we can multiply it by any future value to get the present value. So again, here's the formula. 1 divided by 1 plus the interest rate, which is in B, again, $6, raised to the, use that hat or caret sign, $A7, and we get this factor. And I want it to be the same number of decimal places, so I'm going to make it 4 places after the decimal. And again, I'll just copy it across, and then copy it down. And so, for example, suppose you're going to receive $1,000 10 years from now at an interest rate of 4%. What's it worth to us today? Well, we take the 1,000 and we find this present value factor. We take 10 periods. Where does it intersect 4%? It's 0.6756. So 1,000 times 0.6756 is $675.60. So that's the present value of $1,000 received 10 years from now at an interest rate of 4%. Okay. Here's the future value factor for an annuity. Remember, an annuity is a stream of equal payments made at equal intervals, and this formula is actually for an ordinary annuity. That is, the first payment is going to be received paid or received 1 period from today. And this is the formula, 1 plus r raised to the teeth power minus 1 divided by r. So it's a little tricky formula. Hopefully I can get it right. I've actually done this video several times and messed it up, so I keep redoing it, and I'm hoping to get it right this time. I'm going to put in 3 parentheses so that I can calculate this part, and this part. So I can kind of separate out these 6. So this is 1 plus r, and again, this is B $6, and this is going to be raised to the A7 power, $A7. So I'm going to close that parenthesis. So I have just this part, minus 1. I'm going to close this parenthesis, and I'm going to divide it by B $6. I hope this works. And I get a factor of 1. And while that looks kind of confusing, that is correct. It's correct because the first payment is made 1 period from now, so you don't get any interest, okay, regardless of the interest rate. So you'll notice these are all going to be 1. Now, if I've done the formula correctly, we should see different numbers down here for period 2, 3, etc. And we do. That's good. So, for example, if you save $100 a year for, let's say, 12 years at an interest rate of 6%, what are we doing here? So this is 12 years, 6%. So we'll multiply 100 times this. So you would have $1,686.99 in your account. Okay, think about it. You've saved $1,200, right? $100 a year for 12 periods, but you're getting interest, and so you're going to have much more than that. And again, this formula is quite useful, or this table. If you don't have a financial calculator, this is kind of frustrating to remember the formula and to punch it into your calculator if you don't have a financial calculator. Okay, let me do the last one, and hopefully I can get this one right. Present value of an annuity. Here you're going to have a stream of payments, okay, and we use this, for example, to value a bond, or what's the value of, I won the lottery and I won, $50,000 a year for the next 20 years. What's it worth today? And the formula is 1 minus 1 over 1 plus r to the teeth power, okay, divided by r. So again, let's see if we can put the formula in here. This is going to be a little bit tricky. Let me put in I'll put in 3 parentheses here. Let me put it in this way. 1 minus 1 over 1 plus the interest rate. Here I've moved the rows down, so the interest rate is in B8, $8. And I'm going to close up that parenthesis, okay, for that. And I'm going to close it one more time, and I'm going to divide it by R, which is in, wait, I didn't raise it to a power. Hold on. So I'm going to raise it to the teeth power, which is in A, so $A9. And close that parenthesis. And then divide it by what's in B, $8. Whoops, I did something wrong. Let me see if I can. Okay, 1 minus 1 over 1 plus R raised to this power. I don't know why it gave me such a, why it beeped at me, but it did give me an answer. Let me see if I can copy this across. Okay, it seems to have worked. I may have had one too few parentheses. Okay, so here's the factor here, and I'm going to take a peek in the book that I have to make sure I've got the right numbers. These seem to be okay. These are the correct numbers. And so, for example, let's say you save $100 a year for, or somebody's going to give you $100 a year starting next year for 10 years at an interest rate of 5%. What's that worth to you today? What's the present value of that? That's going to be $772.17. So it's rather nice to work these out. It's a little tedious. Okay, some instructors may actually ask you to construct a present value or future value table. Again, it's a good exercise in Excel, but it also lets you understand what your financial calculator is doing.